It is section 8.3, hierarchical clustering. Here, we'll begin with basics for hierarchical clustering. There are two main types in hierarchical clustering. One is agglomerative and the other one is divisive. In agglomerative nesting, so-called AGNES, it works in a bottom-up manner. Each object is initialized as a singleton cluster, and in each iteration, the two closest clusters are merged into a new bigger cluster, and this procedure is iterated until all points are merged into a single cluster. So here, now AB is nearest each other, then merged to be a cluster AB. And here now D also later merged to become a cluster. And again, C is merged for that cluster. And then and so on. Later on, here, every object becomes one cluster. So it starts from bottom and now reach at the top. Okay, that is AGNES, agglomerative nesting. And the divisive hierarchical clustering is the opposite. And divisive analysis is called Diana, and it works in a top-down manner. And the algorithm is on inverse order of the AGNES. It begins with the root, that means here in the top, and start with one cluster, including every point, and repeat the most heterogeneous cluster is divided into two until all objects are in their own cluster, so that from here top down manner it is working. In fact, this tree is upside down tree, and this is bottom and that is top. Okay, here agglomerative clustering is good at identifying small clusters because it begins from small clusters. In fact, the singleton clusters, while divisive or hierarchical clustering is good for large clusters. It's quite natural consequence. Here we have complexity. The optimum cost is order n squared because each time it should compute the proximity matrix, and here n is the number of points. But in practice, here the computation cost is order n cubed in many cases. There are order n steps, and each step it requires order n squared computations. Now, along with a good arrangement, the complexity can be reduced to order n squared log n. One n is changed into log n for some approaches, but basically in practice, most cases, the computation cost is order n cubed. Okay, here, for hierarchical clustering, we have limitations. It's greedy. Once a decision is made to combine two clusters, then it cannot be undone. And here, for this hierarchical clustering, it's hard to define global objective function. But in clustering, the global objective function is preferred. And most algorithms have problems with one or more of this. And these algorithms are the same as for the partitional clustering algorithms, the sensitive to noise and outliers. And also, it is difficult handle the different sized clusters and non-convex shapes. And sometimes it can have chaining or the breaking large clusters. So AGNES or the Diana will have one or more problems out of these problems. Here we compare hierarchical clustering and K-means. And K-means and K-methods require the number of clusters. K must be user specified, and initial assignment of the data must be given so that the location of means or methods must be given, and also a distant measure between data points must be provided. But for hierarchical clustering, it requires only a similarity measure between groups or clusters of data points. So it is a little bit flexible, and in fact, it is producing a series of the clusters, so that in each level you can specify the clusters. If you work up to this level, then you can see there are 1, 2, 3 clusters. If you go up to that point, then there is only one cluster. And if you go down here, then now you have 1, 2, 3, 4, 5. So that each element, each point is a cluster. So that depending on the user's interest, you may choose the level of clusters. Okay, that is the basics of AGNES and Diana. Okay, we'll continue in the second part. Thank you.